perpendicular lines. This is going to be review for us. We did this last year, and so we can use this information later in the chapter on applying it to different problems. So as far as parallel lines are concerned, two different lines that never intersect are parallel lines. So they go on forever, they never touch, never intersect, they are called parallel lines. And when it comes to slope, parallel lines, as you remember, have the same slope. The same number of slope, that means they're parallel. So let's look at an example here. The question is, which two lines are parallel and how do you know? If you look at all three of these lines, they look parallel. You're just looking with your eyes. But what we need to do is prove it. So what we're going to do is find the slope of each, and then any ones that we get the same slope, those are parallel. So look at the blue one. The first thing we need to do is jot down our points. So we have -3, 2, and -4, -2. I'm going to use my slope formula, which, as you remember, is y2 minus y1 over x2 minus x1. When I pop those in, I get -2 minus 2 over -4 minus -3. That's going to give me a -4 over -1. That gives me a slope of 4. Okay, let's move on to the red. So I'm going to use the same formula. For the red one, I have 1, 3 and 0, -2. Once again, let's do y2 minus y1 over x2 minus x1. That's going to give me -5 over -1, which is 5. So you can see they're pretty close, but those are not the same slope, which means the blue and the red are not parallel. Let's take a look at the green. So for the green one, get some more room here. My points are 4, 1 and 3, -3. So 4, 1, 3, -3. So I'll use my slope formula again. And that gives me a slope of 4 also. Okay, so you can see the blue and the green are parallel. That would be your answer. The red is close, but it's not parallel. What I'd like you to do is pause the video and try that on these two. And then when you're done, hit play and check your work. Okay, so if you did both of them, you should get, for number 1, that the blue and the red are parallel, and they should both have a slope of -3. And for number 2, it should be the red and the green, because both of them have a slope of 4/3. Okay, let's look at one other kind of problem for parallel lines. This one says, are the given lines parallel? So you may remember we've talked about horizontal and vertical lines. When you look at these lines here, this should be an equal sign, sorry. When you look at these lines here, remember that any line that says y equals is a horizontal line. So if I just sketch this quickly, y equals -5 is going to look like this. And y equals -3 is going to look like this. So yes, they're parallel. So we can really go ahead and make a rule. If you have y equals a number, those are always parallel to any other y equals a number. And while we're at it, if you have x equals a number, that line is always parallel to any other x equals a number. Okay, and that only goes for horizontal and vertical lines. So vertical lines are parallel to each other. Horizontal lines, other way around. So vertical lines are parallel to each other. These two are vertical. And horizontal lines are always parallel to each other. Okay, and that's only when you have y equals a number or x equals a number. They're parallel to the same one. Okay, so what I'd like you to do now is go ahead and try these on your own. So hit pause and do that, and then hit play and check your work. Okay, so if we look at number 3, We've got a y equals and an x equals. So immediately you can say no. These are not parallel. And if you were to graph these, y equals 0 looks like this. X equals 0 looks like this. Okay, so those are not parallel. And if you look at number 4, those are parallel. We have an x equals and a y and another x equals. Those two are parallel. If we graph those, they're going to look like this. X equals -4, x equals 1. Okay? So, just to review, when these are the same and there's just numbers on the right, they are parallel. When these are different and there's just numbers on the right, they are not parallel. They're actually perpendicular, and we'll get to that in a minute. So one more example I want you to look at, we're going to do this one together. It says the vertices of a quadrilateral are those points. How can you use slope to determine whether this quadrilateral is a parallelogram? So let's just talk about the terminology here. Quadrilateral just means 4 sides, remember? And parallelogram, I said, a parallelogram has 2 pairs of parallel sides. So a parallelogram can look like this. It can look like a rectangle. It can also look like this. Okay, like a slanted rectangle. Those are both actually parallelograms. But you notice they have 2 pairs of parallel sides. So this one and this one are parallel. And then this one and this one are parallel. That's how we show it. Same thing on here, right? This one and this one are parallel. This one and this one are parallel. So let's take a look. If we plot these points, let's see what we have. So we have -5, 3. 1, 2, 3, 4, 5, 3. And we have 2, 2. 4, -3. And -2, -2. Okay. So this parallelogram, this quadrilateral looks like this. The question is it a parallelogram? So maybe it kind of looks like this one, but we're not really sure because we have to do this mathematically. Well, the way that we're going to test this, we're going to find the slope of this and the slope of this and see if they're parallel. If they are, we'll move on to these two, this one and this one. So if the yellows are parallel and the pinks are parallel, this is a parallelogram. If not, it's just a quadrilateral, which means it still has 4 sides. It just doesn't have 2 pairs of parallel sides. Okay, so let's look at the yellow points first. So for the yellow points, we can do that in orange because I don't really want to write in yellow. The yellow points I have -5, 3 and 2, 2. So let's find the slope of that one first. Remember, we're going to use our slope formula. And I have 2 minus 3, 2 minus -5. That's going to give me -1/7. And if I take the other two yellows, I've got -2, and 4, -3. And that gives me -3 plus 2 is -1. 4 plus 2 is 6. So -1/7 and -1/6. Okay, so those are not parallel, so we're done. We actually don't have to check the other ones. Because the yellows are not parallel, those 2 sides, this is not a parallelogram. Okay, if they were, we would move on to the pinks. So as long as we have 1 pair for the yellow, 1 for the pinks, and they're parallel, these are not. The other thing I want to talk about in this video is perpendicular lines. So we said parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So we talked about this last year, but let's just review what that means. If one has a slope, remember we use m for slope. If one has a slope of 1/2, the perpendicular slope is the opposite, which is negative, and reciprocal, which is flipped. So the perpendicular slope of that is -2/1, or we could just say -2. Okay, one more example is the slope of something is -5. We use the opposite, which is positive 5, and reciprocal, which is flipped. That's going to turn into a positive 1/5. Okay? So, perpendicular lines, they intersect to form right angles, which means they're going to look like maybe this, and there's the right angle, or they can look, they can be diagonal, of course. Maybe they look something like this. But once again, you can't completely tell by looking, so you have to use the math and see if they're negative or reciprocal. Okay, let's do an example with this one. So number 4 says, which two lines are perpendicular and how do you know? We're going to do the same thing we did before. We're going to find the slope of each line, and then we'll see which two are negative reciprocals. Now you can see right away, think to yourself, which two are not perpendicular totally, absolutely? The blue and the red, right? Those can't be perpendicular. They look almost parallel, but they're not perpendicular. So what I'm actually going to do first is find the slope of the green, and then see which one is perpendicular to the green. So the green one has 1, 2, 3, 4, 0, 5, and -2, -2. So my slope formula is going to give me -2 minus 5 over -2 minus 0, which is going to give me -7 over -2. So that's 7/2. So think to yourself, what slope am I looking for if I'm looking for a perpendicular slope? Right, I'm looking for a -2/7. Okay, if I can find a -2/7 slope, that will be a perpendicular slope. So I'm going to try, I guess, the red one. It kind of looks closer, who knows? So the red one is -5, 1, 2, 3, 4, 5, 0, okay. And 2, -2. So that's going to be y2 minus y1, x2 minus x1. That gives me -2, perfect, 7. That's what I'm looking for. So I'm done. Okay? So the green one is 7/2. The red one is -2/7. Those two are perpendicular because it's a negative reciprocal. Okay, so that's your answer. I'm going to pause the video here. What I'd like you to do is move on to part 2 now. There's just a little bit left in part 2 to finish up. So go ahead and move on to the next video.